Hello everyone, I'm Archana Menon. Today I will discuss about the topic OSI Reference Model in Computer Networks. This is the agenda. ISO OSI Model. ISO stands for International Standards Organization. It is an international organization for standardization. OSI is a model called Open Systems Interconnection. The model was fully developed in the year 1984. An open system is a set of protocols that allows any two different systems to communicate. OSI model facilitates communication between different systems without requiring changes to the logic of the underlying hardware and software. The OSI model is not a protocol. It is a model for understanding and designing a network architecture that is flexible, robust, and interoperable. Therefore, ISO is the organization and OSI is the model. The 7 layers of OSI model. The OSI model is a layered framework for the design of network systems that allows communication between all types of computer systems. It consists of 7 separate but related layers, each of which defines a part of the process of moving information across a network. The 7 ordered layers are physical layer being the first layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer, the 7th layer in the OSI model. Now, let's see how the layers are involved when a message is sent from device A to device B. As the message travels from A to B, it may pass through many intermediate nodes. These are the intermediate nodes in this transmission. Each layer defines a set of functions which are distinct from those of the other layers. The OSI model allows complete interoperability between otherwise incompatible systems. Within a single machine, each layer calls upon the services of the layer just below it. For example, layer 5 uses the services provided by layer 4 and it provides services for layer 6. Between machines, layer M on one machine communicates with layer M on another machine. This communication is governed by protocols. Protocols are a set of standard rules. The processes on each machine that communicate at a given layer are called peer-to-peer processes. Communication between machines is therefore a peer-to-peer process using the protocols appropriate to a given layer. Each layer in the sending device adds its own information to the message it receives from the layer just above it and passes the whole message to the layer just below it. At layer 1, the entire packet is converted to a form that can be transmitted to the receiving device. At the receiving machine, the message is unwrapped layer by layer with each process receiving and removing the data meant for it. You can see interfaces between each layers. Each interface defines the information and services a layer must provide for the layer above it. The upper 3 layers, that is layer 5, 6 and 7, act as the user support layers. They allow interoperability among unrelated software systems. And these layers are always implemented in software. Lower layers are a combination of hardware and software. Now, let us see how a data exchange takes place. Here, D7 means the data unit at layer 7, D6 means the data unit at layer 6, and so on. The process starts at layer 7, the application layer, then moves from layer to layer in descending sequential order. At each layer, a header or possibly a trailer can be added to the data unit. Commonly, the trailer is added only at layer 2. Now, what is a header and a trailer? Header or trailer are control data added at the beginning and the end of each data unit at each layer of a sender and removed at the corresponding layers of the receiver. When the formatted data unit passes through the physical layer, that is layer 1, it is changed into an electromagnetic signal and transported along a physical link. The transmission medium could be a twisted pair cable, coaxial cable, optical fiber, or radio waves or any other medium. Upon reaching its destination, the signal passes into layer 1 and is transformed back into digital form. The data units then move back up through the OSI layers. As each block of data reaches the next higher layer, the headers and trailers attached to it at the corresponding sending layer are removed and actions appropriate to that layer are taken. By the time it reaches layer 7, that is the application layer, the message is again in a form appropriate to the application and is made available to the recipient. Now let's understand the meaning of the term encapsulation. Here you can see that a packet, both the header and data at level 7 is encapsulated in a packet at level 6. The whole packet at level 6 is encapsulated, that is wrapped in a packet at level 5 and so on. In other words, the data portion of a packet at level n-1 carries the whole packet from level n, which includes data and header and maybe trailer. This concept is called encapsulation. Coming to the conclusion of this topic, the 7-layer OSI model provides guidelines for the development of universally compatible networking protocols. Hope you understood the concept of OSI layer. Thank you.